I'd first like to begin by acknowledging the traditional owners of the land on which we meet today, and I'd also like to pay my respects to their ancestors and their descendants. Yeah, so today we have Dr. Naoki Katayama, who is, as he said, who is an academic visitor to my group, and he will be staying here with us until next April for a whole year. So please welcome his visit. And he did his PhD at the University of Tokyo, Japan, and since then he has been a principal investigator at the National Agriculture and Food Research Organization. It is a huge research organization in Japan about everything related to agriculture and food security and so on. And I think he's giving a talk about his recent work and also his plan on what he's going to do during his visit at CBCS today. So if you are ready, please go ahead.
Thank you for the introduction, and thank you all for coming to my talk. I'm happy to share with some of my previous work with you, and an ongoing research project to show the importance of rice ecosystems for global biodiversity. First of all, I'd like to thank all the people and the organizations that supported my family and I to come here from Japan. Especially, I'd like to thank Center for Biodiversity and Conservation Science, the University of Queensland, and Dr. Katayama for their kind supports. I also acknowledge the traditional owners and custodians of the land and its history that I have been able to meet you. And I'm also grateful to my family who support me every day. Okay, so I'm going to start from my research background briefly. We know that agriculture is the main driver of global biodiversity loss. However, we also know that agriculture is very diverse, and biodiversity impacts of agriculture depend on a variety of factors, including historical land use, landscape heterogeneity, and the management practices. In this talk, I'd like to focus on rice, which is a staple food supporting more than half of the global population. As shown in this map, rice is produced in many parts of the world, especially in Asia. And rice fields are important, not only for food production, but also for biodiversity conservation. For example, rice fields are known to critical habitat for some shorebird species using the East Asian Australian flyway. For example, this picture showing the gray-tailed foraging in Japanese rice paddies in spring during their migration. In addition, previous study also showed habitat use of water birds in rice fields in North America, South America, Europe, and Asia, many rice producing countries. Of course, conservation of natural wetlands should be a higher priority, but in regions and countries where much of the natural wetlands have been already lost, understanding and enhancing the habitat function of rice fields is of great value. For example, in Japan, more than 5,000 species are recorded in rice fields, including many threatened species or near threatened ones, such as intermediate invasive. Therefore, there has been increasing interest in biodiversity conservation in rice ecosystems, not only in Japan, but also probably many other rice producing countries. Based on the background, my first question was, does organic rice farming increase biodiversity? Regarding this topic, previous meta-analysis showed that compared to conventional farming, organic farming can support higher species richness, about 30% in average. This list is not comprehensive, but summarizes major findings, including mine. However, there is a geographic bias in such scientific evidence. This means that most studies have been conducted in Europe and North America, and wheat and vegetables are the focus. So however, such dry farmlands are very different habitats from rice paddies, mainly in Asia. Of course, organic farming is practiced in wider regions, such as South America, Australia, India, China, and Japan. So these facts show the presence of spatial bias in the knowledge of the biodiversity benefits of organic farming. To fill this kind of knowledge gap, my colleague and I conducted a nationwide field survey with the support of Ministry of Agriculture, Forestry, and Fishery in Japan. In summary, as time is limited, we surveyed plants and animals in more than 1,000 rice fields in total over the 3 years survey period, including conventional rice fields and organic or low input rice fields in many parts of Japan. And this large-scale survey was accomplished with the help of many Japanese researchers in Japan. I'd like to acknowledge these people. We first developed survey methods of native plants, spiders, dragonflies, aquatic insects, bugs, fish, and birds like water birds. And then we counted species richness or abundance of these taxonomic groups quantitatively to compare different farming systems. And as I expected, species richness and abundance of many taxonomic groups were higher in organic rice fields than in low input or conventional rice fields, as shown in this figure. For example, this shows the average abundance of dragonflies in conventional low input and organic rice fields. And organic fields generally supported higher species richness or abundance. This result was probably due to the non-use of chemical pesticides in organic farming, and also the low intensive management. Interestingly, water bubble richness and abundance were positively associated with a proportion of organic rice fields in the landscapes. This figure shows the water bubble richness and abundance, and the x-axis shows the proportion of organic plant rice fields in the survey landscape. And there are positive relationships between them. So this suggests the implementation of organic farming at the landscape scale is beneficial for water bubble conservation. to further investigate the importance of such landscape scale implementation of organic farming, another nationwide project was conducted, which supported the ministry in Japan. In this study, environmentally friendly farming was defined as either organic farming, winter farming, or integrated pest management. And many sites were investigated across Japan. Again, we find that organic farming and other environmentally friendly farming was beneficial for water birds when implemented at the landscape scale. This figure shows the positive relationship between the proportion of such friendly fields in the landscape and the density of egrets and hills. This result is probably because water birds can get more play, such as large tadpoles and aquatic insects in organically managed rice fields. Based on these findings, we recently published a survey manual for non-experts, including farmers. And by using this manual, biodiversity level of each rice field can be rated into 4 ranks, S, A, B, and C, based on the abundance of indicator groups, taxonomy groups. Also, a YouTube channel is available to help people understand field service. Nevertheless, organic rice farming clearly has a disadvantage. This means that organic rice field was 30% lower than conventional rice fields, as shown in the previous project. And this figure shows the trade-off between biodiversity and rice yield, especially for native plant richness. Show the clear trace of relationships. And this problem is probably mainly due to weeds and pests. And this may explain that organic farming is less than 1% of the total farmland area in Japan. Furthermore, some recent articles argue that organic farming is not the only solution for biodiversity conservation in agriculture landscapes. And more importantly, habitat heterogeneity may be the key for such solution. Indeed, there are a variety of potential options to enhance habitat heterogeneity in agricultural landscapes. At local and landscape scales, examples are so many, such as crop diversification and the creation of semi-natural. And my study showed this is also the case in rice fields. In Japan, fallow management practice provides breeding sites for the greater painted snipe, which is predominant species in Japan. The right figure shows in the breeding season, the snipe population tend to immigrate into areas with more fallow fields. And also there are very such fallow fields in Japan. So the creation or maintenance of such fallow area is really important for such bird conservation. And not only fallow management, but also Many other practices may be beneficial for biodiversity conservation at the local scale, such as winter flooding and in-field ditch. In-field ditch means provides aquatic habitats when body water is drained during autumn and winter. To assess biodiversity benefits of such practices, we performed a systematic review of English and Japanese literature. And we focused on 8 types of local management practices, such as organic farming, winter flooding, and low-input farming, and so on. And also 5 taxonomic groups from plants, invertebrates, amphibian, fish, and birds. And we found that 179 relevant publications, mainly from Japanese literature. And to summarize our findings, biodiversity benefits were assessed qualitatively based on the level of confidence, like IP-based assessment. For example, this one shows the positive effect of grassy bank conservation for amphibians, and there are a number of publications, so I can determine the evidence is well established. And we found that different practices were beneficial for different taxonomic groups, indicating the importance of heterogeneity in management practice at the landscape scale. And these enhanced wildlife species can provide important ecosystem services. This is just an example. Increased spider abundance can reduce pest abundance in Japanese rice paddies, which is very important for sustainable rice production in the future. The landscape scale heterogeneity is also crucial for biodiversity. Using nationwide student science data for birds in Japan, I found that mosaic agricultural landscapes support higher bird richness than simple landscapes. This figure shows the relationship between percent forest cover and the bird species richness in agricultural landscapes. And the mixed landscape of forested agricultural land supports the highest species richness, such as Midland. With reference to some of these findings, the Ministry of Agriculture, Forestry and Fishery in Japan has prepared a draft grading plan for rice according to such local practices. For example, organic farming is given a 3-star rating, and low input farming or winter flooding a 1-star rating. Please note this is only a plan, but in any case, scientific evidence and evidence-based certification schemes are really important for effective biodiversity conservation and sustainable food production. Biodiversity modeling will play a major role in promoting such certification schemes to consumers. This is not my own study, but previous studies show that rice with biodiversity labeling has about 20% price premium as compared to rice that doesn't. And this picture shows one of the most famous bird in Japan, like crested ibis. which was once extinct in Japan and subsequently reintroduced. And there are many rice products to conserve these ones. Therefore, such biodiversity labeling may attract greater consumers' interest. To further promote certification schemes, interest or experience in conservation, nature conservation may be crucial. In our study, we performed interview survey to people in Japan. And people with interest or experience of nature conservation showed higher willingness to pay for biodiversity-friendly rice, as shown in this figure. For example, people with higher conservation interests showed higher WTB, willingness to pay for such biodiversity-friendly rice, and also experience with nature conservation activity was important to increase WTB. And also, sexual difference may be also important. This is an interesting note. So I'd like to summarize the story so far. Firstly, organic rice farming is effective for increasing biodiversity, especially at the landscape scale. But given the significant yield loss of organic farming, increasing habitat heterogeneity can provide alternative options for biodiversity conservation. And lastly, such biodiversity-friendly products can be supported by evidence-based certification schemes and increase the interest in biodiversity conservation. Then I will move on to the next topic. When considering sustainable food production, the issue of human depopulation cannot be avoided. In some Asian countries, notably Japan, the rural population is decreasing and is expected to decrease further in the near future, as shown in this figure. Such depopulation has caused land use changes, including land abandonment. Many researchers, including me, are looking at how land abandonment affects biodiversity. And this is also a global topic, attracting many researchers' interest around the world. In Japan, depopulation has caused two types of land use changes. On the one hand, Japan's forests have matured in recent decades. The left figure shows annual changes of standing volume of forests. And both natural forest and the plantation forests has increased in the recent decades. Such forest growth may provide an opportunity for forest specialist wise to increase. On the other hand, depopulation is also associated with loss of open habitats, such as farmland and grassland. In Japan, as shown in the left figure, the area of farmland and grassland has been declined in the recent years. These habitats are abandoned or converted into urban areas. In any case, the nationwide loss of such open habitats can be a threat for various species that depend on open habitats. To test this hypothesis at the national scale, I analyzed the data of bird population trends from a student science project in Japan. Thanks to the help of two non-governmental organizations, the Nature Conservation Society of Japan and the Bird Research. In summary, we used the abundance data of 47 common bird species in 190 birds, showing the black circles, not white circles. Over 12 years, from 2009 to 2020. Because this project is relatively new, the survey period maybe not so long, but very important data. And as I expected, forest specialist birds have increased, but birds using open habitats have decreased over the past 2 years. This figure shows annual changes on average bird abundance, relative abundance of 3 values based on their habitat use. So in this study, we defined forest specialists as bird species that use only forest during the breeding season, and the forest generalists as bird species that use both forest and open habitats, and open habitat specialists which only use open habitats during the breeding season. And this trend shows the geometric means of multiple bird species of each of the two. The 21 forest specialist species, 19 generalist species, and 7 open habitat specialist species. They show contrasting trends between different groups. And interestingly, we find rapid population declines in the last 5 years, which may be associated with recent global warming, temperature warming. Indeed, we also find that bird species with lower temperature niche declines more in the last 12 years. The y-axis shows the population trend of each bird species, and the x-axis shows its temperature niche plus measured as the difference between minimum and the maximum temperature each species distribution range. So this result suggests that recent impacts of global warming may also explain the bird population trends. Of course, further research is necessary to explore detailed process causing the trends. Okay, I'd like to summarize this story. Human depopulation causes various changes, such as forest growth and open habitat loss. There are both winners and losers of these various changes, and the losers will more focus on their conservation. This is especially true in Japan because forest is a dominant land use and cover about 70% of the total land use. And also climate warming can be additional threat for biodiversity. Finally, I'd like to move on to a new research project with Dr. Katayama. It's about how rice fields can contribute to nature-based solutions. For climate change, human health, food security, and biodiversity conservation, and so on. Detailed approach is under consideration now, but systematic review and meta-analysis to compare biodiversity and other outcomes between rice fields and other values, maybe once. For example, in our previous study, we compared biodiversity between cultivated rice fields and abundant rice fields in Japan. And we find that the overall effect size was negative, indicating that rice fields support higher species richness or abundance than abundant fields. Such approach may be once. To proceed this project, collaboration with researchers around the world is essential. This is because multilingual review is crucial to collect knowledge from many rice producing countries such as Asia, Europe, and South America. Now I'm collaborating with these kind of people, but more people are welcome to join. Okay, I'd like to finish my presentation. Any comments and questions are welcome. Thank you very much.
Thank you very much, Naoki, for this amazing talk covering a lot of different research. And I'm sure there are some questions from the audience. Questions?
Thank you. That was so fascinating. A lot covered. One thing that caught my eye was the trends in forest cover in Japan over time, including even native forests increasing, but also that, yes, right. Yeah, and plantation forests overtaking natural forests and cover. Are those, what are the plantation forests? Are they made of native forest species, or are they introduced species? And what does the composition, what does it do for the composition of birds and things in those plantations?
Your question is about the composition of the plantation.
Yeah. Are they native plantations?
Yes, plantation of native. I'm sorry, I don't know English name.
Or like the species
Yes.
of trees?
Yeah, no.
Same, yeah, are they the same sort of trees as in the natural forest or totally different?
Yes.
It's the same. So that's probably really good for the birds. And then do you get similar bird species in those plantations as you do in the natural forest?
No, there are difference in bird species composition between natural and plantation forests. Yeah. This is a very important point. But generally, both forests volume increase. So, yeah, especially for natural forests will be beneficial for the birds, but also plantation forest has a role for supporting some forest bird species.
And why is natural forest increasing? Is that from natural regrowth or are people planting?
That's a great point. I think this is because natural forest is not managed, and so the area doesn't change, but the volume increased. So natural forest is growing to higher and higher.
Oh, right.
The volume
Okay.
is increasing.
Got you. Sorry, I missed that. So it's just taller. So it was previously it was cut and it's been let grow and not cut again.
But due to human depopulation, forests are not managed, less managed. So both plantation and natural forests getting higher and higher.
You know, if forest area is changing.
Yes, that's good. The forest area is almost stable during the last. So just the volume is changing, increasing.
Thank you very much for that presentation. Very, very interesting. I was wondering whether some of those local practices that you mentioned, like the winter flooding and the infield ditch, are they practices that don't really result in a loss of rice yield, or do they still slightly compromise the yield of the rice?
Thank you for very important question. Yeah, that's a great point. And yeah, probably these practices also cause yield loss to some degree because in this area, rice cannot be planted, of course. And also, I'm not sure about winter flooding, and there is very few such yield data in Japan. So I'd like to collect such production data in the near future. Thank you very much. Yes.
I think it shows the trade-off between
Yes.
yield and biodiversity, but we know which practice especially reduce the yield.
Yes, so I think I need to analyze this data for more detail, but in Japan, weeds are the biggest problem to reduce rice production. So the non-use of herbicides can increase some type of harmful weeds, which result in the great reduction in rice yield sometimes. But this is also important, but I think weeds are the biggest problem in Japan, in many parts of Japan. So, there is a clear trade-off relationship between plants diversity and rice yield. But also some variation exists, which is very interesting. I'd like to examine for more detail why such variation exists, which may be necessary for our future win-win situation with biodiversity and rice production. Thank you.
Thank you for the interesting topic. Set my mind going in lots of different directions, but I'm curious about richness, which was used here and in the heterogeneity assessment. And I'm just curious because it's not necessarily, it doesn't tell you the community structure, right? So you don't know if the organic farming is letting in pests or letting in desirable native species. I'm just curious, there's either in this study or the landscape heterogeneity study, if you knew whether the community structure or the species involved were things that you would want to conserve.
Yes. Yes. This study also only examines species, but not species composition. So in the near future, I need to examine what species causes such yield reduction, what species associated with either increase, such as spiders are useful natural elements for some pest species. So yeah, species identity and composition crucial for understanding or mitigating such trade.
Yeah, because some amount of yield loss for really endangered species would be like, okay, maybe we can make that trade-off, but if it's just for species that you're finding elsewhere, common species in some way, then maybe not so much. And the landscape heterogeneity, habitat heterogeneity one, you would expect higher biodiversity in the ecotone right in between. But I think, like, again, the question for me would be like, which species? In that one as well, if the landscape heterogeneity, yes, it's going to have more richness, but is it good richness? Is it species that you want? Don't we love to say that? Bad richness.
I believe it's good rich.
Good richness. Okay.
Sorry about that. Huge scientific.
Yeah.
I guess in one view research on the effectiveness of organic farming, you compare the certain species between
Yes.
conventional farming, so it's not necessarily about the heterogeneity component.
This shows the number of listed plants, which are slightly. So organic farming was beneficial to the investment. But in this project, harmful weeds or pest species were not investigated. So we need to investigate. Or
You mentioned before about looking at maybe something in wins, for the rice yield and the biodiversity. Are there some practices that you think might achieve that win-win, that farmers could easily implement on their farms? Is there some of the different local scale farming practices that might get you the biodiversity gain, but also maintain the yield so that you're not sacrificing any yield?
yes, that's very important. What's shown in this figure, we have a variety of options which are known to be biodiversity. But we have few data yield loss regarding these practices. So yeah, your comment is very important. So we need to investigate how these practices close rice yield reduction. So, this is future trend. Thank you very much.
Can you go back to the slide that you were showing with the, all the different taxonomic groups? Yeah, I'm curious about, sort of the richness or abundance for these species in, organic, rice fields versus just unmodified, non-modified wetlands. So like a normal, a wetland, like a natural wetland versus the rice
Yes,
field.
yes.
And is it how those relate? Because again, I'm wondering if you get lots of yield from non-organic farming.
Yes.
And then you keep wetlands, or is it more organic farming and taking over more area? So
I understand your comment is regarding land sharing spelling issue.
Yeah.
So yeah, this is very important point. So but there is a few scientific data comparing organic farming and natural wetlands. But I believe that natural wetland really support higher biomass. So yeah, we need to consider the role of land scale compared to such land sharing approaches. But there is already a few natural wetlands in Japan. Natural wetlands have been already lost or degraded due to human activities. So of course we have higher priority for natural wetlands conservation, but at the same time we also consider the usefulness of such land sharing.
So if there's no other question, thanks very much, Naoki, for this excellent presentation. I'm hearing be listening here for another year, so please come to talk with me for any potential collaboration or anything about Japan or partnership and so on. Thank you very much.